Hello, everybody. We've got another visual pattern challenge for you today. And this one's kind of an odd looking one. Here's step one in our pattern. Here's step two. Here's step three. And the challenge here is to look at this and be able to predict how many of these blue circles are going to show up in step number four. If you can do that, can you predict how many will show up in step 43? And along the way, could you write an equation to predict the number of circles in any step at all? So that's the challenge. If you'd like to accept it, pause the video, see how it goes. All right, well, this is an odd one, and I think, I see sort of like a hollow square with a corner missing here, but then two sides of the square get much thicker. I think actually to sort of see what's going on in this pattern to make some visual sense out of it, I'm going to start with step number three and try to block off some chunks. So what pops out at me here is this rectangle, this big 3x4 rectangle. And then it looks like we've got another exactly the same size there, 3x4. And that just leaves these three odd ones. So one on each end and one in the middle. So can we see that same pattern in the previous steps? Well, let's see. Here's another bigger rectangle. This time it's 2x3. And there is one over here too, so that makes sense. And that leaves the 3 like we had before. It's a little harder to see that pattern in this one, but I think I can. So here's a 1x2. Here's a 1x2. So we've got two rectangles, and then the 2 on the end and the 1 in the middle. So those 3 constant there. All right, so I think that actually is enough information to predict what's going to happen in step number 4, right? So these rectangles, first 1x2, then 2x3, then 3x4. So this rectangle should be 4x5. And then there'll be another one up here, 4x5. And then we've got these 3 dots, so one on either end, and then one in the middle. So the numbers then for step 4, 4 times 5 is 20. There's 2 of those, so that's 40 plus the 3 others. So it looks like we've got 43, that magic number, as the number of circles in step number 4. But what kind of a pattern is this? And I think for step 43, it's going to be much easier if we have an equation. So let's analyze the numbers and see what's happening here. I don't think this is a linear pattern, but we'll verify that by looking at the numbers closely. So I'm going to make a chart here with the step number and the number of circles. So in step 1, we've got 4, 5, 6, 7. In step 2, these are 6, 12, 13, 14, 15, okay? In step number 3, we've got the 3x4, so that's 12, 24, 27. And in step number 4, we're predicting 43. So once we've got the numbers arranged, we take the differences to look what's happening between each step. 15 minus 7 is 8. 27 minus 15, that's 12. And 43 minus 27 is 16. Okay. We did not get a constant in the set of differences. It means it's not a linear pattern, and that's what we suspected anyway. Let's take the difference of the differences, because if we get a constant in that second set of differences, then we know we have a quadratic going on. So 12 minus 8 is 4, 16 minus 12 is 4. Aha, so we do have a constant. So we know we're dealing with x squared in this as sort of our highest term. In the past, if you've been doing these videos up until now, you've noticed we've often arrived at a 2 here. And when we did, this constant in the difference of the differences, when it was a 2, our leading term in our equation was always x squared. We've got a 4 here. What does that actually mean? Well, I actually arranged a spreadsheet here. I've got an equation, so this is y equals x squared, and then I put in several steps, what the value would be, the y, or the number of circles, or whatever you're using in your pattern. So 1 squared would give you 1, 2 squared would give you 4, etc. And then I took the differences, and then the difference of the differences, which is what we need when we look at a quadratic. And you can see in this plain old y equals x squared, the difference of the differences is 2. When I did y equals 2 times x squared, same thing, so listed out some step numbers and then did the calculations. So 1 squared times 2 is 2, 2 squared times 2 is 8, etc. Then I took the differences, and then the difference of the differences came out to be 4. So it looks like, and actually let's do one more. So this is y equals 3x squared. When I did that, the difference of the differences came out to be 6. And then when I did 0.5 or 1/2 x squared, the difference of the differences came out to be 1. So whatever number you get in this difference of the differences, divide that by 2 and you will get the coefficient of your x squared term. And this can be really helpful in trying to write an equation. So since we got 4 for our difference of our differences, we know it's going to be a 2x squared. So that's a handy thing to know. So we've got 2x squared. And I think then to work on the rest of the equation, we might want to just block out, I'm going to choose another color here, might just want to block out, maybe orange is too close. We'll do green. Block out 2x squared in each one and see what's left over. It's going to be a little confusing because I've already written all over this, but that's okay. So here's 1x squared, here's another x squared, right? Because 1 squared is just 1, and this is step 1. Then here's 2 squared, and here's 2 squared. So that's 2 of the 2 squareds, and we'll do the same thing here. Again, I think this pattern might be easiest to see in step 3. There's our 3. Okay, so in each step now, in the green, I have blocked out 2x squared. So this portion of the equation is satisfied. What is left? Let's look in the step 3. What's left is this, which is 3, this, which is 3, plus the 3 odd ones we always have left over in every step. Those 3 odd ones left over in every step, I think, are going to be a plus 3 on the end of our equation. So that's out here as a plus 3. What is this line of 3 and this line of 3? Well, that's just the step number, right? So that's 2 of them, so that's 2x. That same pattern repeats here. So we have the 3 odd ones, that's our plus 3, but then we've got this row of 2 and this column of 2. That's an x and that's an x. That's the step number. So that's 2 times x. Same thing here. You can think of this as x and this as x, and those as the 3 odd ones out. So in each step, we've got 2x squared, 2 x's, so 2 of the step number squared, 2 of the step number, and the 3 left over. So this is going to be our equation. That was pretty tough. So if you got to this, I think you should feel pretty proud of yourself. Now, to get to how many in step 43, we have y equals 2 times 43 squared plus 2 times 43 plus 3. So there's a lot of calculation to be done there. I'm going to pull out my calculator for this. So 43 times 43, that's 1849. Now we want to multiply that by 2. So that gives us, so this is just this chunk, 3,698 plus 2 times 43 is 86 plus 3. So plus 86 plus 3. And on my calculator, I am getting 3,787 of those little blue circles in step number 43. Well, how did that one go? I think that was a really tough one. Did you get 43 for step number 4? Did you get to an equation like this? Let me know. Thanks, everybody.